Hey everybody, it's Kendall. I just wanted to, all right, let's get started here. I'm sharing my term project. I looked at S. cerevisiae. Not sure if that's totally how you say it, but its common name is yeast. And the family and genus. So the family is Saccharomycetaceae, and then the genus is Saccharomyces. And then there's a lot of different species of S. cerevisiae underneath that. What does it do? It ferments sugar from carbohydrates in flour or barley and turns them into carbon dioxide to make dough rise for the bread or to create the alcohol for the wine and beer. Let's look at the three: beer, wine, bread. Beer is generally mostly domesticated strains of the Cerevisiae because of the environment it's kept in. Because it's kept in an environment in like a brewery, which is indoors, it's mostly domesticated strains. Wine is mostly kept outside in wineries and like vineyards, so it is mostly wild strains. And then bread, most use domesticated yeast, but a sourdough starter or something like that would use a mix of domesticated and wild. Where do you find it? It's very easy to find in man-made ways, such as at wineries, breweries, etc. It's very hard to find in natural reservoirs. It's usually found in bark, leaves, and soil of oak trees if it is found in a natural place. And so for adaptations, yeast has adapted for better brewing. It's adapted to resist sulfite that was used to clean wine bottles. This created better fermentation of the wine, so it resisted that sulfite and was able to still go through its processes. It also adapted to brew malt beer better, containing maltose utilization within the strains. It interacts with a couple of other bacteria, specifically lactic acid bacteria during cheese ripening to produce aromas, also with others to lower ethanol production, where the yeast will gain ability to utilize other carbon sources and the bacteria will get reduced toxic effect. So it's good on both ends. So is this good or bad? Like, what is this? Good, it's significantly sustainable and it does not produce toxins to air, land, soil, sea. It can lead to an increase in N2O and CO2 emissions, so that's like not great. One fun fact that I found was that this can be added to livestock diets and it can have changes in the gases produced by them and they actually improve rumen condition. So it can be actually a very important environmental factor if you add this to the diets of livestock.
Hi there, this is Crisanto. I did my project on a species of parasite called Schistosoma hematobium. They're also known as blood flukes or schistosomes, and they're a parasitic flatworm, and they come from the Schistosoma uh, genus. And blood flukes are important because of the cause of one of the most largely unaddressed diseases of poverty in the entire world, um, called schistosomiasis, also known as bilharzia in some places, and some people refer to it as snail fever. And this waterborne parasitic disease is one of the most rampant, right behind malaria, affecting over 200 million people across 76 countries. This particular species is prevalent in parts of the Middle East and Sub-Saharan Africa. I will share with you my graphic novel. The target audience is student professionals, particularly in the science and health field. And just, I've been thinking about how science and particularly microbiology has been applicable in my life. There's a lot of value in understanding how microbes function, how we live alongside them, especially in the pathogenic sense, because those of us that can't even get like the most basic education, um, can link with the most marginalized people, with the poorest people in the world. There's over 200 million people that this is affecting. There's a lot of opportunities to like share this knowledge and help people solve their own problems in their own communities. And you don't have to be an expert to do stuff like that. You just have to go, link with them, share. Easier said than done, but it's so needed to be spreading our expertise in this way. So, graphic novel. When I was your age, I was sitting right here on the riverbank the day my sister came home with 2 university students. She called the whole village together, and alongside the students taught us why the river has made us sick. What made us sick was not bad deeds or the ghosts that curse water. They taught us about the parasite that burrowed through our skin, a flatworm called schistosoma. Since they rove through our blood vessels, they're also known as blood flukes. This one is schistosoma hematobium. They taught us about how the flatworm looks for us in the river. The hematobium reproduces inside the human host, and fertilized eggs exit the host through the urine. And once they're in the water, they swim and develop into ciliated larvae called merozoites. The merozoites finds an intermediate host, the Belianus snail, and inside of that snail, they go through asexual reproduction that results in a motile or a mobile larva called Cercardia. And the Cercaria respond to changes in light and temperature, and they're also attracted to fatty acids on human skin. And once they find its human host, it attaches to the skin and then penetrates. And in humans, they cause schistosomiasis, also called bisharia, and we call it snail fever. Once the Cercaria find its primary host, us, they attach to the skin with its suckers. And to pierce the skin, they secrete an enzyme that widens the hair follicle large enough for the larva's body to enter into the bloodstream. It makes its way through the circulatory system, heading for the veins surrounding the bladder, where it will ultimately grow into adulthood. On its way to the bladder, many of these larvae are killed by our own immune cells, even though S. hematobium has the ability to coat itself in molecules that keep the immune system from suspecting it as an invader. S. hematobium blood flukes get nutrients from human blood, specifically the red blood cells that carry oxygen from our lungs to the rest of the body. It metabolizes the blood through its gut and can absorb the nutrients directly through the surface of its body. And since the flatworm makes its home in the blood vessels surrounding the bladder, it's constantly bathed in the nutrients it needs for growth. To reproduce, the male blood fluke envelops the female in a cleft that runs along the length of its body called a gynecophoric canal, and they stay coupled for their entire 3 to 4 year adult lifespan like this, and laying 500 to 1,000 eggs a day. The eggs that don't penetrate the walls of the host bladder get stuck and aren't able to exit the body through urine. The infection brought on by these stuck eggs are the main cause of bilharzia, rather than the flatworm itself. The human body's immune cells try to fight the blood fluke's eggs as an infection and create an immune response where the cells surrounding the eggs clump together, eventually building up so much that lesions are created and the cascade of symptoms of schistosomiasis onsets. And my sister brought us to the dam. The mining company built 10 years before. When the dam came, the prawn disappeared. There was nothing to eat the snails that parasites need to grow. This is when the snail fever started. But we fought hard against the dam and the mining companies to get the river back. When the dam was released, we started to see the prawn again. You can still find a few snails the parasite used to use here, but the fever has gone from us for good. Thank you.
Hello, my name is Cassandra Carroll, and this is my final project, which is an overview on malaria. So malaria is a very prevalent disease in the world. In 2019, there were a total of 227 million cases reported, whereas in 2020, there were a total of 243 million cases reported. Many people believe that that increase in cases was largely due to the disruptions caused by COVID-19 and a lot of the endemic regions that are endemic to malaria were not able to receive the aid that they needed. Therefore, malaria was able to spread. 80% of deaths, unfortunately, that were reported were children under 5 years of age. The endemic regions of include sub-Saharan Africa, the Amazon region of South America, Burma, and the Mekong region of Asia. This is just an image of where malaria is the most prevalent, including obviously the endemic regions. And those are indicated by the bright red areas on the map. So malaria is spread through the Anopheles mosquito. The specific causative agent of malaria is actually a protozoan unicellular eukaryote, which is an obligate parasite. These species include Plasmodium falciparum, which is the most virulent, so it causes the greatest amount of death related to the disease. Plasmodium alveoli, Plasmodium vivax, and Plasmodium malaris. After being bitten by an infected mosquito, symptoms typically occur 10 to 15 days after the bite. Symptoms include fever, headache, and chills. However, specifically with P. falciparum, it can progress very quickly and lead to death within 24 hours. Malaria is so deadly because it actually causes red blood cell sequestration in the tissues and in microvasculature. So it basically causes little micro obstructions throughout the body, which ultimately leads to organ damage and failure. This is specifically important with pregnant women because it actually can obstruct blood flow to the fetus, leading to low birth weights and anemia. And it can even cause the baby to be born with patent malaria infection. So how is malaria spread specifically? So an infected mosquito will bite an individual. When it's biting the individual, it will inoculate the wound with the infective stage of the parasite, which are called sporozoites. And they do this through the transmission through their salivary glands. And this is part of my art project here, where the sporozoites are being spread and passed through the mosquito into the human. So the sporozoites then travel via the bloodstream to the liver. And once in the liver, the sporozoites are taken up by the hepatocytes, which is the functional unit of the liver. Once in the hepatocytes, they're now considered merozoites and divide rapidly in a process known as schizogony. Merozoites are then released into the bloodstream. Once the merozoites are in the bloodstream, they actually multiply asexually via schizogony and are continually released into the bloodstream. About 8 to 64 new merozoites are released per red blood cell, and this process is continually repeated within the body, spreading the disease very quickly. However, some merozoites will differentiate into gametocytes and undergo sexual reproduction within the mosquito. The gametocytes must be taken up and activated within the hindgut of the mosquito. So without the presence of the mosquito and the mosquito taking up the gametocytes, they would not be activated. So you have to have the mosquito in order for malaria to reproduce, basically. And this is just the mosquito taking up the gametocytes. So as mentioned earlier, the specific environment of the mosquito hindgut activates the gametocytes. This allows for the reproduction of new sporozoites, and the cycle continues. Interestingly, the Anopheles mosquito, the reason it is the vector for malaria is that it is a strong carrier of the TEP1 gene, which protects them from the malaria disease. Therefore, they're perfect hosts for the parasite. So what are the solutions to malaria? The actual number one most powerful and cost-effective tool to prevent malaria are insecticide-treated nets. It's very cheap and can be widely accessible to many people, as well as anti-malarial drugs. So if you're ever traveling to an endemic region, doctors will insist that you be put on anti-malarial drugs for your safety, as well as indoor residual spraying and vaccination. Hopefully with these methods, the spread of malaria disease will decrease and we can actually get a hold of this awful illness that kills millions of people every year. Thank you.